Good morning, everybody. Hopefully everybody's having a nice start to their Wednesday morning. Thank you for joining this month's free MicroView webinar. Excited to have you guys. We're gonna go over a few topics today, talking about leveling today, gonna talk about using the calculator a little bit more. Got a ton of feedback from you guys about doing more calculator functions. See how that can assist you in your inspection and reporting processes. I'm excited to talk about offsetting features and, like I said, leveling today because as I'll say a little bit later, sometimes depending on fixturing, I rarely level, but the more and more that I get into advanced programming and setting up systems to just be the most solid system I can, you see more and more the importance of leveling, even on the vision system, even if it's a flat part. So we're going to go over some of that stuff today. See if we can, there we go. So a couple things I want to talk about up front. Again, feel free to jump into the chat box, send any questions along the way. And say hello to Dan in there. And if you guys wouldn't mind, I had one person message me that they can't hear me. I just want to make sure that everybody can hear me. So if you would just do me a favor and pop in the chat box and say good morning. There's Dan saying good morning. A couple things that I want to talk about is upcoming events that we have going on. So we'll have a September webinar. You guys can sign up now. You guys love getting those emails from me for signups. Hopefully they're not too annoying for you guys. Go ahead and sign up for the September webinar when I send you the follow-up. Quality show is coming up in October in Rosemont, Illinois. Great opportunity to be able to walk the quality show, see all the new inspection equipment out there, see some fixturing companies, and of course, come visit us at the ATI booth. I got to figure out what number we are. I should have had that prepared. But come visit us. And during the quality show, we're going to be hosting a training seminar. So we host 3 to 4 day training seminars, and we're kind of making this the best of that 4-day training seminar into 3 1.5-hour sessions with a break in the middle to be able to walk the quality show. I'll talk more about that here in a second. And then we are planning a Chicagoland 4-day training seminar. Still looking at locations, best central location off of easy highways for a lot of Wisconsin and a lot of Illinois to be able to come and join that. So like I was saying, October 27th, Rosemont, Illinois, we'll be having this training seminar. We'll start the morning off with hand gauge training, learn the proper usages of the hand gauges, verifying them, in between your calibration cycles to make sure that every day you're using a verified good gauge. Blueprint reading. So this is really good for those looking for a review of blueprint reading and also brand new techs to the quality industry to kind of give them a head start on learning how to read blueprints. And then we'll all walk over to the quality show and you guys are free to roam, grab lunch, and then check everything out. We always love going to the quality show because you get a bunch of free pens and stress balls in all different shapes and sizes. Dan got one 2 years ago that was a sheep, and that's our lab mascot now. And then MicroView datums as systems. So it's an hour and a half of just complicated systems, setting the right systems to match your datums, or if you don't have datums on your blueprints, just making sure you have those solid systems so you have a repeatable and accurate program. So $100 per person, or if you want to come to all 3 sessions, $250, and then your quality show ticket is free. And then we would love you guys to join us after the training seminar for some food and beverage and a networking event. Meet your local sales rep if you haven't met them yet, and meet the team, the inspection team, and some other ATI employees to help you guys out in any way that we can. So enough with announcements today. I want to do a little July webinar review. So we talked about using part separator function, keeping your data organized, measuring multiple parts. If you're using SBC software, this could be very useful, keeping track of your features list. So if you translate your part 10 times, it's easy to find where each part starts and stops. And then easier for copying and pasting from the Excel sheet that MicroView exports into your inspection sheet. We also talked about flatness, and I will be the first one to say that I am not the smartest person in the room, and I do not know everything. And I always like to say that when I start any training seminar, class, or anything like that. And I'm so thankful for you guys joining. And when I say something that actually isn't true or not the right interpretation of a standard, you guys send me an email and say, hey, this is actually how I interpret it. So I know that gentleman is on today, so I want to say thank you in front of everybody. So when I was talking about flatness, when we have this symbol, you guys can see my cursor here, it had this square next to the flatness, so we have two flatness readings. I was taught a long time ago in a blueprint class that that was meaning one thing when it actually meant something else. So it actually means the size of the controlled increment, not the number of increments. So I thought you took that surface divided by 10, put 10 planes on there. It is actually the size of each plane going on there. And I hope I am explaining that correctly. So if you guys joined last month, wipe that out of your memory, and I can send you this part of the standard so you guys can read up on it as well. But I just wanted to say that in front of everybody that I'm not always correct, so do fact check me sometimes. And if I interpret a blueprint wrong or a standard wrong, I would love to learn from you guys. And this gentleman said that he's been teaching metrology and blueprints for over 40 years, and he learns something new every time. And that's why I love teaching, is because I learn something new every time. So thank you, and correcting my last webinar there. We also talked about point cloud, extracting max and min Z heights of a plane, and also just using point cloud to extract raw data as much as you see fit and need. So you're not tied to if it's just a circle and inspec. We talked about kind of taking all that raw data out. So I can send you the recording of that if you would like, let me know. And we started talking about the calculator function and all the different things that are in the calculator function, and we'll hit that a little bit today. But we talked about finding, if we have 10 diameters, finding the max, min, and average of all 10 diameters using the calculator function. Calculator function is super powerful. And there's times that you're trying to figure out how to calculate something that InSpec maybe doesn't have the option for in its normal presets. You can always look to the calculator function. And I would actually love to hear from you guys in your feedback surveys, or send me an email of ways that you're using the calculator function, so I can use that for a future webinar to teach everybody else. So first thing I want to talk today about is the rectangle tool. Kind of funny when Dan and I and other trainers go through features, we'll bring up the rectangle tool or we'll bring up the ellipse tool, and we get a lot of either blank stares or people just tell us we never measure rectangles. But it's funny that I've had 2 projects in a row that are using true positions of the rectangle tool. So I figured, hey, why not spend a little time talking about the rectangle tool. So when I measure a rectangle, when I measure a slot, when I measure distances, gaps, angles, anything, I measure the features first. You are able to come and just click rectangle and go measure your 4 edges of the rectangle, but then those lines are tied to the rectangle and you can't use them for other distances. If you measure 2 lines and as a distance, you are not able to use those lines for anything else except the distance. Same thing with angles and even slots. When I measure a slot, I'll do the 2 arcs and I'll do the 2 lines, and then I'll click slot and I will click all those features to create that feature. So I did a little prep work this morning, doing a couple programs. So we have kind of hard to see here because I disabled all the features, but I just wanted to be able to find my way around this part quickly. So we'll measure it live. I'm going to go ahead and turn on my surface light. And we got this plastic part here, a couple different posts going on. So with the rectangle tool, I'm going to come over here. We got this feature that the blueprint is calling out the true position of the center of this rectangle that we have going on here. So the very first thing that I am going to do is I'm going to set up my datum structure, which on my blueprint, it says that this post right here, the center of this post, is my origin of X and Y. So I'm going to go ahead and click circle. Let me go ahead and delete that. I'll run the program. There we go. So I'll click circle. It's disabled. I'm going to go ahead and delete all that. There we go. My vision tools were disabled for some reason. I think it was trying to have me run some part of the program. Anyways, so I'm going to measure this with an F-scan circle. As I've talked about in previous webinars, I'm going to have the red arrows going from the dark to light because there's less gray value going on, and then it's able to scan that circle there. And then now I'm going to come over, I got to find my datum B, which is right here. There's this circle that we're going to use to skew to. I'm going to go ahead and turn on profile light since it's a through hole. And while I see this fixturing, so this diameter right here is actually one of the threaded holes on my fixturing plate. Few people have requested more topics on fixturing. One little tip and trick with fixturing here is that if you want to avoid having any of the acrylic scratches or glass scratches or dealing with the threaded holes in your plate, maybe lift the part up a little bit so this gets blurry. That'd be a smart thing to do if you're trying to write a fully automated program that's not going to scan any wrong lines. So here I'm going to use just best edge points real quick to measure this diameter. So I'm going to call this datum A, which datum A is usually a plane, but we'll call that datum A. We're going to call this datum B. So now I'm going to come down. I'm going to set my origin of X, Y, and Z. I should get a focus point for the system, but for time's sake, I say that a lot. I'm just going to set my origin of X, Y, and Z to that. And then I'm going to skew to those two circles. When I skew to those two circles, it's doing a line straight through the center of both circles. If you are more of a visual person and you want to skew to that actual line, you could click line and you could click your two circles here and you could skew to that line. But I like clicking less and getting results faster. So I'm just going to skew to those two circles there. So now I got my origin over here to this diameter, and I'm skewing between these two diameters. So now let's go to that rectangle tool. Here's a little trick I like to do is I like to turn on my axial light because on the part, it's a smaller circle of light, so it's easier to find where you actually are on your camera. So it's a little way to move around the part without knowing where it's at, the feature's at. So on these edges over here, I'm going to come measure this line. I'm going to bring the Z up actually to get it in focus. And I'm going to select line. I'm going to do more inputs so I can get both edges of the line. I'm going to use my F-scan line tool. Measure one edge here. I'm going to flip that arrow because there's a lot of noise, gray value going on over there. And then since I have more inputs selected, now I got my line going on over here in the top left corner of my schematic window. I'm going to click a new line, come down this edge. Get as long of a line on that edge as possible. I'm going to switch over to surface light so I could see the end of this part here. I'm going to do line again, more inputs. I'm going to get the best. So you can see here in my points view, and I'll open up a large view here. We can see that our points, they're kind of scanning on that line. We got that best fit line going through the center. It looks pretty good. If I had this opened up a little bit, you can see how much more dramatic the edges get, or the points landing. And you can see down here in my camera window, those blue dots are where the line or the points are actually scanning on there. So I actually want to flip that edge, get these windows out of the way, flip that edge and get a nice line on that surface there. And normally, if I was programming this for production, I would spend a lot more time on my lighting to figure out the best lighting. While we're here, let's go ahead and switch some surface lights and octants to see if we get any better lighting going on. Switch to axial light. That's a lot worse. Let's switch to front. Now we're casting a shadow over that wall. I don't like that at all. I'm actually going to click on the left side octant, hold down Control, select the right side octant. So those are the ones only with polka dots. That actually, doing from side to side, we actually get a little bit more shadow cast in that groove that's going on. I'm going to bring that over to avoid that, whatever that is going on there. All right, so I'm going to switch back to profile light, do a new line, more inputs. And then now we have our four edges of our rectangle. So now I can come down here and select the rectangle tool. I see a lot of first-time users, since they both kind of look like a plane, get the rectangle tool and the plane tool confused, but always remember you could hover over an icon, click and it'll show what that tool is. And also in our basic training manual, there's a page for every single icon down there that you guys can have at your desk in case you forget. So I'm going to now select all my four edges of my rectangle, and it creates my rectangle tool there. What I use this for is if it's asking for a true position of this rectangle, I can click point, and now I can click my rectangle in my features list, or you can come over to the schematic window and it creates a center point. So now I have my XY coordinates that I'd be able to get my true position from on there. And things that we can tolerance with a rectangle, we can tolerance the center X and Y, we can tolerance the width and length of it, width and height of it, actually. We can tolerance the true position of it. So if we did 2.30 and then 0.54, it calculates our deviation from nominal. Let's just put it out of tolerance just to show you. Close, and then we have our true position out of tolerance there. So another thing that you could do is, if you don't want to use the rectangle tool, we could do a line. We can use the bisect construction tool, which will give us, if I click the both long edges of the rectangle, we get our center line. And then if I click line and I click the short edges of our rectangle tool, we get our other bisect line. And then we can do point intersection of those two bisects there. So a little more work than just clicking the rectangle tool. But in case you need these center lines for anything as well, they're there for you to work with. And like I said, the reason that I don't like doing the rectangle tool first and then measuring the lines is, now if I wanted to do a distance from this edge to say datum B, we're able to get that distance there. That's the rectangle tool. If you guys have tabs or other rectangle features on your parts, where I've been seeing it in the projects coming into our lab here in Bartlett has been the tabs of off-roading vehicles and just plastic parts that are being clipped on to the frame or other plastic parts. They need true positions of those rectangles like in this blueprint here, it was asking for the distances from those on there. So that's another thing, you know, we love you guys sending us sample parts and blueprints to use on the webinars. And then also if you ever send parts for third-party inspection, so you need us to inspect them, if you are willing or able to, let us use the examples on a webinar. Let us know. We like using real life examples so you guys learn more. Here's a little thing that I wanted to talk about. Schematic window and the different things that are in the schematic window. So if you are on your schematic window, and we'll go live here on Inspect in a second, but I want to show you this gray box is your camera window. And this can get confusing that if you're at the end of your program and you're clicking around in your features list, it's showing you snapshots and it's showing you where that snapshot is. But this crosshair down here is the actual machine location. So sometimes if you're moving the part around, if I go ahead and I click on this circle that's datum B, you can see that my gray rectangle over here is the camera window, but that's showing what's in the camera window. My actual live location of the machine is over here on the rectangle. So this could get confusing sometimes, that if I know, all right, I want to go to datum A over here, and I'm here on this circle and I start moving to the left, I'm actually way over to the left of the part, and I have to come over. And now when I'm moving the camera live, the crosshair and the gray box are in the same location. So I've seen a couple people get mixed up with this when they're programming or in training. So I just wanted to mention it real quick. If this kind of annoys you or you're trying to show somebody something, it's just a little tip there. All right, calculator functions. When we are measuring circles, most of the time when you're reporting true positions, you might either give a positive X and Y or absolute X and Y on your report, or you might report the negative direction, negative, positive of it. So wherever this comes up, if it's true position and you're reporting, or if it's going into an SBC software, and when we measure a diameter, if you want to report an absolute number, but MicroView is reporting it as a negative number because the location of it in relation to your datum, we'll be able to pull that absolute number out of there. So here we can see that our datum is in the center of the part, same part that we're using live, and our diameters here, number 1, is in the positive X and Y coordinate of the part. To the left of that is number 2. That's where it goes negative X and positive Y. Down in the lower left-hand corner, you have negative X and negative Y location. And then lastly, number 4, you have positive X and negative Y here. So it's kind of nice because it's alphabetical order in the calculator functions. ABS is your absolute. So in this case, my X location of circle 2 is reporting a negative X location, but I wanted to get the absolute to go into my SBC software. So I clicked absolute function here, and then I clicked my diameter 2, ended it with a parenthesis, hit calculate, and it comes up with the absolute location there. So let's see if I go back to this guy. I'm going to enable this whole program so we can measure it. So in case you didn't see this in the previous webinars, you can highlight features, right click, and go to this playback option, and you can disable or enable it. So I think I showed last month or the month before using a spline to outline the whole part and then disabling the spline just so I had some reference of where my part is on the stage and other features. I'm going to go ahead and enable all this. File save. Let's go ahead and run this program. So this is about to go into a little bit of another topic we're going to talk about here in a minute, but offsets. So this system down here, I actually want this. So if we were looking back at our slide, we're seeing that the top left corner of where my datum is, where my system is, I have negative X and positive Y. But I actually want this diameter to be negative X, positive Y. But the way that I have the part on the stage is that my system is to these two features here. So here's a quick workaround that we could do. We could come down to, in the red construction icons, we see this offset here. We can open up offset and we can rotate about Z. So in this case, I want to rotate around Z 90. And now you can see that my origin turned 90 degrees on here. So now when I hit the PCS view right here, now my diameter is positive, positive up in the up right corner. Now I have my negative X, positive Y on this diameter, and so forth here. So I have these two locations. I want to come over here to circle 2. I can come click the calculator function. I can double click absolute. I will select my circle that I want to get an absolute instead of a negative number here. And it comes up with anything that a diameter is measuring, everything from XY location to profile to position, concentricity, circularity. So I'm going to click X. I'm going to say I want my actual, not the deviation, but if there's anything that you're looking for to pull out of a feature, we could, ask for what's the out of tolerance amount, what's the lower, upper, deviation from nominal, and so on. So I'm going to click actual, calculate, and now I got my positive result that you can right click, you can tolerance, or you can export, whatever it is. Basic dimensions, so I'll leave that, and then I'll export it. And then now I'm exporting a absolute number instead of exporting that negative number. So this is useful for, other than true position or anything else, anything reporting, any software you're bringing into, don't be rotating your system so you get all these positive in any certain way. You can do that. Another thing with negative and positive numbers that I find very useful, I'm going to create 2 lines off of this guy and this guy. I'll do another line here and here so I can get an angle. So I'm going to use the angle tool, select my 2 lines, and now you can it comes up with these different angle options that we have. Down here, depending where your angle is in relation to your system or your part, your skew, you can select positive or negative numbers. Where I use this the most is that an angle is just an absolute number when you're putting on your inspection sheet 90% of the time. But depending where the angle is on your part in relation to your system, you could get a negative number. So when I copy and paste it off of my Excel sheet, I always have to go into my Excel sheet and say, make all these cells absolute, when in my programming, if this was negative, I can just use the calculator function, absolute, click my angle. I want my actual, and then we got our absolute angle number there. And then you can go tolerance it, export it. Now with SPC software, I'm not completely sure, I'm a little unfamiliar with it, how it'll pull in the calculator function if you're labeling it angle. That's something we can help you with if it kind of messes stuff going up in your SPC software. We can get, if it's ProLink, we can help get them involved to help you out with whatever works the best for your situation. I say this a million times, but these webinars are to show you the tools in your toolbox. If you never have to use the 10 millimeter for a year, but then all of a sudden you need to use the 10 millimeter socket, you know where it's at and how to use it. But here's an example of the angle that I was talking about. Awesome. So the next thing that I want to talk about is offsetting features and construction features. So in this instance here, we have a blueprint that's actually wondering on this cone that we have going on here on my sample part, at a certain height, what is the diameter on that cone? So it was halfway down the cone and it wants to know what's the diameter at that height. Using construction icons and the offset features, we're able to do an intersection of a plane and that cone to be able to get our diameter at that intersection. I'll come over to inspect here. Let's go file new. Again, I say it all the time, pop your questions into the chat box if anything comes up, or if you see another example that you would like to see while we're talking about this as I'm switching out parts. Put that little machine block on the stage here. Again, I went and measured the outside edges of the block so I would be able to find it easily. Here on the webinar, you guys can do that to give yourself the outside features to work yourself around on the part, because now I can, in my schematic window, click move here where I want to go. So first thing we're going to talk about, I know that my cone is somewhere in this area here. And boom, there it is. Because I had my disabled lines, I'm able to click around in my schematic window a lot faster. I'm going to go ahead and get this surface in focus. I have not had luck with focus points in the past. I think it's because of WebEx messes with the video card. So let's see if this works. Hey, look, it's working today. We're going to run with it while we can. So I'm going to go ahead and do a plane on the top surface of my cone and keeping it local. Even if the top surface of this part is datum A and you want to take 1,000,000 points around datum A, for this case, I would still do that, but then go make another plane that we can offset down, because we don't want to offset datum A and mess up the rest of our system. So now I'm going to go ahead and measure my cone. And yes, I should be at a higher magnification for accuracy in Z. But in this case, I want you guys to see the whole feature while I'm going around. So now I'm going to click cone. I'm going to click more inputs. And I'm just going to start taking focus points around this cone. And it's able to use that focus point and Z measurements to know the different levels of this cone. I'm probably going to do more points than I need. I apologize about background noise. You guys can hear that. Shipping is extremely busy here at ATI. So here I'm going to hit the isometric view. You can start seeing my cone. I'm actually going to hit the front view because I want to make sure that my cone, the top of my cone, is almost as parallel as possible to the plane to make sure that I'm getting a real good reading and my focus points are creating that 3D cone the best it can. And if you hold down the scroll wheel on your mouse, you're able to move it around kind of like CAD software if you've ever used that before to move it around. So now, make sure that I'm in inches. Yep. Now I'm going to click plane. I'm going to copy plane 1. So you can either click it in the schematic window or you can click it in your features list. So now I'm keeping my original plane so that doesn't get changed. And then I'm going to copy the plane and I'm going to offset that copied plane. So I'm going to come down to my construction icons down here, find the offset icon. And I'm going to say I want to offset that negative, let's try 0.1. I don't have my blueprint on me. So my memory serves me correct. So I just offset that plane down 0.1 of an inch to get it to the location that we want in to get that diameter there. So I'll run through that one more time. So I'm going to copy. So I'm going to click plane. I'm going to click plane 1. So it copies plane 1. I'm going to come down to offset. And I want to offset, I want to bring that plane down negative 0.1. And your blueprint will tell you what height that it wants the diameter at and all that. So here we go, isometric view. We can see our two planes, our cone. So now I can click circle because we want this diameter that is intersecting this cone and this plane here. So I'm going to click circle. Now I'm going to use the intersect tool. You can use the intersect tool for intersection of two lines, intersection of a line and a circle. In this case, we're going to intersect the plane and the circle here. So now I click intersect construction icon. I'm going to click my plane and I'm going to click my cone, and it gives us that diameter at that height that we needed in the cone there. Other ways you could do this is you could, if you had touch probe, you'd be able to set your origin of Z to the top plane, and then you would be able to bring your touch probe down negative, whatever it needs to do, take that plane there. But if you don't have touch probe, this is one way that you can get that diameter at a certain height. Try this out on other features, knowing that you can offset planes, offset circles, offset lines, anything that's maybe on your blueprint that you can't physically measure, because when we're looking at this cone here in the camera window, even if I come over, if I said my origin of Z was this top plane, and then I wanted to do a focus point at a certain height, I can right click in the camera window and say move to absolute -1, and it brings my camera up to that plane, up to that height, but still looking at this cone, I don't necessarily know where to place my focus points there. But if you're physically touching it with a touch probe, that would work on that. So other things with construction features is, and leveling, I want to show you when to level and why it's important to level. You can see here we have this angled surface. When I take this diameter without leveling, it makes the plane, I never know how to say this, parallel with the camera or perpendicular to the camera, but basically it's flat. Microview is always thinking more in the 2D. The software is thinking 2D, even though we can do 3D measurements. So if we took a diameter at different Z heights, like we will on this diameter over here, even though it's at different Z heights, it'll either average the Z heights or it'll place it where we have our origin of Z, something going on there. So we can see that this diameter that's not on the plane, this dashed line here, that's not leveled. But when I leveled the plane and took the diameter, it took the Z measurements into account. So if I was measuring this part, most of my features are on the top surface. So I'll put it on a fixture in some sort of way that those are this plane, so that's looking at the camera when we can level. And also, you can see over here, I'm going to show you an example to keep track of your levels, because the one that is angled, I was still in my system that had it leveled to the left plane, not the top plane here. So it was actually placing those points leveled with that plane. Let's go ahead and do that live here. Hopefully my focus points continue to work here for you guys. So I know that my plane is somewhere over here in the lower left-hand corner. Move my surface lights up a little bit. So the first thing that I'm going to do is I'm going to measure a plane, use focus points. And these kind of topics of leveling, setting origins, and skews, if you've been through our formal training or if we've come and done like on-site application training, we talk about the importance of setting systems and what to set systems to. Dan's going to be teaching the datums and systems session at our training seminar in October. We're going to talk a lot about complicated systems and how to make your systems the most solid they can be to get all your different measurements. And I'm sure you guys, if you've been programming for a long time, you've had probably 5 to 10 systems in one program, especially if you've seen a blueprint that has double letter datums. You need to do a lot of that. So now if we look at our isometric view, we can see that we got our angled plane right here. So if I don't level, if I don't set an origin or anything, and I come over and I take this diameter, I'm going to place a point there. I'm going to bring my Z up to get this edge in focus. I'm going to take a point there, bring my Z up, take a point there if it'll read it. And since I didn't level, you can see that it is going parallel with the camera. And that's not the diameter we want. So if I set my level to this plane, just so the schematic window looks good, I'm going to set my origin X, Y, and Z there. Now when we come take the diameter, you can even see that the scanning tools are leveled with my system. Now we have the circle on the surface that we actually want. And if we look at the difference between the two diameters, one not leveled is 0.48, 12 millimeters for those that are in metric. And then our level diameter is 0.567. Huge difference. And that is either way in tolerance or way out of tolerance on there. Now, my latest system that I have is that leveled system. Now, if I move on to the rest of my part without thinking, and now I'm on my top surface, I come measure this diameter without setting a new system. Now that diameter, even though it's physically parallel with the camera, it is level to that plane. So in this case, what I like to do is if I have any angled surfaces or anything like that, I'm going to set that system later. I would set the system that I want to the top plane so I can get out of that system. So what I mean by that is my very first system is going to be thinking more 2D. What's more flat? The top plane is flat, parallel to the camera. So I'll set that system first before leveling to an odd, not parallel with the camera surface. So glad my focus points are working today. Now when I set my origin, I level to my plane, set my origin to that plane. When I take this diameter here, it's going to be on the correct plane that we have going on. Super important for more 3D parts. Microviews, like I said, are always thinking 2D, but we've talked about flip working planes before. We've talked about leveling now. This is where you really pull the 3D features and the 3D programming out of the microview and make the microview more powerful than just measuring flat parts or certain features. I saw Christina just asked a question. Yes, so when I'm programming, I like labeling my system so I can keep track. So this one, I might say top plane, And then when I come over, I would do this feature different. But Christina asked, you need to set level and origin to the slanted plane as well. I actually want you guys to forget about me setting my origin X, Y, and Z to the plane. I've been doing that just to get it out of the way of the schematic window because it goes to the machine coordinate system when I just level to a plane. I've been doing that. I would set my origin of X and Y to a diameter or an intersection point. Skew to a line or two circles. And I wanted to show you here, you can see that now that I've kind of set a new level to this, my Z is going in this weird direction this way to the top left corner. And this is why you want to set your origin X and Y to a diameter, something like that, not the plane. But then if we come and measure this diameter, we see that that diameter now is leveled to this plane. And if I copied this circle down to the new system, up here you can see in your parent system that it's looking at the latest system that is in my features list. So this is another topic that we're going to talk about in datums and systems at the training seminar, is if we right click on that circle, I can set my system to a different system. So in this case, top plane, and it'll level to that one on there. So if you do mess up where you measure this diameter in the wrong plane, you are able to right click on a feature, set system, and you can set it to whatever system you have going on in your features list, and it'll change it to whatever that level is on there. So before we wrap up today, I've said it a couple times today, we are hosting this training seminar. You can register on our website at atiquality.com/events. You can email Dan and I at training@atiquality.com or respond to the email that you're going to get in about a half hour following up from this webinar here. You know, I think it's pretty low pricing for a full day of training plus the quality show. And then we'd like to see you guys all at the networking reception afterwards. If you don't need hand gauge training or blueprint training, you can come to one session. You can come to the quality show, stay for mic review, and then stay for the networking reception. You can pick and choose whatever it is. If you guys have a large group that wants to come to the quality show, let me know. I probably can do some group pricing. But I think it's going to be a great time. It's going to be the best of the training seminar. So if it's something that you want to bring your boss to get a taste of what the full 4-day training seminar, so you can attend that this winter when we host it somewhere in the Chicagoland area, that's a great opportunity as well. So think about these sessions as the most important information of hand gauge training, blueprint reading, getting your team off to a great start. And also feedback that I've gotten from other training seminars is it's nice to get the whole quality team or production team on the same page of how to use hand gauges and verifying them every gauge per shift, so you know that you're using quality tools, which will prevent you from having more rejects or you know, having to quarantine parts in between your calibration cycles on those certain features or on those certain gauges. So we'd love to see all you guys at this training seminar. Hand gauge training is a little bit more limited seating due to the gauges that we have for the class. Blueprint, plenty of space, and mic review, plenty of space for you guys to come. So yeah, email me back, let me know. And last time, we did have a winner last time, and I emailed them. I don't want to make anybody jealous for winning or not winning, but we're going to give another free seat away for the quality show training seminar. Follow us on LinkedIn, review, recommend, or post tag about Assurance Technologies, this webinar, calibration, anything positive, hopefully, on LinkedIn. We would really appreciate that. And as always, time for Q&A. I know this goes to 11. You guys got to probably get back to actually measuring parts and hopefully using the skills that you've learned today. But feel free to pop any other questions in the chat box that you have. And we can hopefully measure them live or show live, or feel free to pop them in there and we can get back to you later. So thanks again for joining today. And hopefully I see some of you interested in the Metrology Training Seminar. So thank you again for attending. If you don't have a question or want to stick around for any of the questions, thank you again, and we will see you next webinar in September.